I'm Mike Legatt. I'm ERCOT's Human Factors Engineer, and I have the honor of moderating this panel today. We've got a lot of incredibly talented, experienced folks here who are kind enough to lend us their experience as we talk about ITOT convergence. So thank you for all being here today. So across all of the layers of the grid, excuse me, from the system operator down to the individual consumer, what used to be two different types of devices are starting to come together. For example, at the grid level, you see synchrophasers, or at the residential level, internet-connected thermostats. They all play significant roles in the reliability of the grid. But these devices are also becoming much more like IT devices. We're moving from a world of things to a world of internet-connected things. For example, you can now run a firmware update on your thermostat, and you need to make sure the thermostat is connected to the network, has really strong cybersecurity, and really good uptime. According to the DOE, a resilient electric grid is arguably the most complex and critical infrastructure. US Presidential Policy Directive 21 states that the energy and communications sectors, above all the other sectors, are of critical importance because all of the other critical infrastructure sectors depend on them. And frankly, in many ways, talking about ITOT convergence is talking about energy and communications coming together. And that means that we need to make smart decisions and better transitions. Now, as a representative of the grid operator for most of Texas, we often get the question, are you a reliability and operations organization, or are you an IT organization? The answer is yes, we're both. But when you have two different organizational types with different cultures merging together, how do we pick the best and the right practices from both sides to help build a more reliable, secure system that grows into the future with our society? How do we grow not to just get deeper and faster data, but also have the new types of devices change the work that we do, the way that we support operations and support the grid? So to help address some of these questions, we have some really talented folks today, and I'm honored to have them all. So I'll start with Matt and ask everyone to please introduce themselves and just give us a little intro to your background.
Okay. Good morning. My name's Matt Lampe. I'm the Chief Information Officer for Los Angeles Department of Water and Power. LADWP is a sort of traditional, still vertically integrated utility. We run about, I think, 7,300 megawatts of our own generation, about 20%, a little over 20% now renewables, and run our own transmission for the most part for that power. A lot of our renewables are up in the Pacific, our wind up in the Pacific Northwest. Those were some of our earlier renewable projects. So we use Bonneville's transmission to the Oregon border and then bring that down on our own lines, and then do our own distribution. So we haven't experienced some of the things that have gone on in Texas that I think California tried some DREG, did a very bad job of it. And as a municipal utility, we were left alone, and I think fortunately at that point in time, because they really had not figured out the models. But running in a vertically integrated utility, the ITOT issues come up in spades, and we are our own balancing authority. So.
Oh, excellent. Well, thank you. Sir.
Morning, I'm Bob Welch. I'm Vice President at Veatch. I run something called the Operational Technologies and Analytics in our management consulting business. You probably know Black & Veatch is a 100-year-old energy-focused engineering, program management, construction company, built some of the most significant electric, water, gas assets in North America. Management consulting business is really focused on a number of specific areas around advising clients on the basis of investing in capital investments in assets, how to run those assets, and in our case, how, whether, and when to acquire technology to improve the performance of those assets. So we work with clients, largely, I'd say 80% of our clients are electric distribution companies, although we work actively with the others as well. Been very active in smart meter rollouts, including here in Texas. But really for us, and I come from, frankly, more of an IT background, so I sort of live at the intersection of these two things. More around moving from the implementation of individual technologies in that enterprise to really looking at what I think of as more transformational projects to improve the overall performance of the distribution network in particular. So,
Thank you.
Well, good morning. My name is Jeff Norman. I'm Vice President of Emerging Technologies with Leidos Engineering. I want to get a show of hands here between me and the door. If you're IT focused today and here in this meeting, can I get a raise of hands? IT, okay. Now the OT folks, okay, we were taking, okay, come on, don't be, get them up, all right.
Almost adds up.
Yeah, we're just trying to figure out our path to the door as we have this conversation today. No, it's our pleasure to be here. This is my second ETS. Leidos Engineering is an infrastructure company serving energy, environment, healthcare, and the national security industry. My particular group helps utilities as they use technology to enhance reliability, empower the customer, and enable renewables. It's good to have you today.
Hi, good morning. I'm Wade Malcolm. I'm with a company that's called the OMNETRIC Group. It's a fairly new company, a joint venture between Siemens and Accenture that's been put together specifically to focus on the topic of ITOT convergence. So we get involved in projects that involve the delivery of both information and operations technology. We do custom development. We work on architecture and integration activities in support of technology projects for utilities. And we also do perform a variety of what we'll call advisory services all along the planning, the justification, the benefits realization of this type of work as well.
Thank you very much. Also, you'll see, unfortunately, we have an empty chair at the moment. Raiford Smith of CPS Energy is currently stuck in a forced outage on I-35, so hopefully we'll be able to make it shortly. So great. So let's begin. So let's start with a definitional question. I'll start with you, Matt. How would you define ITOT convergence? Is it simply more granular control or maintenance, replacement, connectivity, and many other facets? And at what level of the grid do you think it's most needed?
Well, let me start with just the basics, right? So in all these things, we talk about technologies, but we also have to talk about people, and we also have to talk about process. And really, the IT-OT convergence is about bringing new technologies that allow us to do things in more real time, whether it's control or intelligence, into the grid. But if you step back, right, everything we did, you go back a number of years, everything you did on the operations side was essentially mechanical. People had to throw a switch, they had to so all their controls were mechanical. And they had interlocks, they had various safety mechanisms, but you weren't dealing with systems that changed. So the mantra of the operational guys forever was, you build it, you test it, and if it works, you don't touch it. You just leave it alone. And so now, as we're trying to do these things that we have to because the grid is becoming more complex, if you've ever seen the output of a series of wind farms, even if the wind's blowing well, you're still seeing things that look like this. And trying to how you balance that into your grid, and as you start going up the scale into the 30–40% renewable ranges that many of us are going to have to be facing over the next 10–15 years, that becomes extremely complicated. So we start then thinking about storage, we start thinking about edge control, we start thinking about these technologies that allow us to react much faster. But they all depend on IT. And IT technology is something, as we all know, is constantly changing. And you can't take the philosophical approach of putting it in and leaving it alone. And that's really a fundamental, the fundamental people issue that's underneath the convergence issues. It's not just about, can we make these complex technologies work? They're tough, right? I mean, show me any very complex IT system that doesn't have a bunch of bugs in it. You're never going to get rid of all the defects. What your goal is to make sure it's secure enough and has the defect counts are so low, or where they are don't have any critical impact in what you're trying to do. And that philosophy is very different than sort of the traditional OT philosophy, where you knew if you threw that mechanical switch, it was going to connect. And so we really have to start merging those cultures. Now, a lot of the industry, certainly in my environment, where you have a very high percentage of people on the edge of retirement. I think in my shop, 40% of my people can be eligible to retire in about 5 years. And across the various parts of the Department of Water and Power, you see a lot of that same thing, and you see it a lot in the utility industry as a whole. That's good news and bad news. The bad news is that a lot of those guys are more skeptical about the bringing in IT technology. The good news is that the people who replace them will be people who are much more familiar with their smartphones and the internet and all those areas. So I think we'll see more receptivity there. But at the same time, we also have to be somewhat cautious. We are dealing with a critical infrastructure system, and the level of integration we're seeking requires a great deal of diligence. And we can't be just rushing out and saying, okay, we're going to throw all this stuff out and we're going to just put this new system in and it's going to work. There's a lot that can be gained, but we have to, us IT folks also have to be somewhat cautious about overwhelming the OT guys, because they have a very, very critical perspective that we have to respect as we move forward.
So definitely plug and pray is not sufficient for this. So let me kind of pull that thread even a little bit farther, which is ultimately, as you mentioned, the IT and OT groups are all working for the same cause, for the reliability of the system. But ultimately, those IT and OT groups may have different, within their areas, different mission statements, certainly different, values and training of their employees. So can you give some examples of strengths of each of the cultures, what they could bring together? And do you have any, can you give some examples of trying to pull the best parts of each of those groups together to kind of create this synergy? So I guess I'll start with you, Bob.
Well, I think, it's interesting. I think that with all due respect to a colleague here, being a CIO in an energy company is not an easy job. And it's not an easy job in any company, I guess, but in this industry in particular, I don't think it's an easy job. And in large cases, it's because the CIO, in my view, often sees the enterprise more clearly than others because they have to support it. There are a set of disciplines and a set of experiences in the IT organization around testing and acquiring new technology and rolling it out, all the things that Matt just said about change management and so on, that don't reside in the operational side of the house, or they haven't traditionally, because as you said, if it works, don't touch it. And so we have largely a workforce in the operational side of these utilities who has a very familiar tool set that they've worked with for a long time, or maybe they've gone through a couple of migrations to more generalized, standard practice is a big deal in the operational side. You can't put technology on something until you standardize the practice, which I think is still an ongoing initiative in most utilities, is just standardizing what they do across the operational enterprise. So I think that in a lot of cases, and we see this clear as a bell in a couple of our clients, the operational technology acquisitions and deployments are often done without all those disciplines that the CIO and his organization understand so well the smart ones, and I'm sure Matt's one of them, have prevented that from happening. But then when you get into, as I was saying to the group earlier, so you have a project and you're rolling out new, say, smart meter technology, and you get into and the rollout is multiple years, and you require devices and software and hardware to support that. And you start rolling out the meters, and all of a sudden you have both a project, which has an infrastructure to it, which could kind of take care of that stuff that goes on, but you're also in business. You're running the business. And all of a sudden, the question starts to come up of, where are all those disciplines around upgrades and maintenance agreements and providers' roadmaps and so on that the IT organization has lived traditionally with for many, many years. So we actually do a lot of work bringing those two organizations together. It's as simple as, how do you budget for this stuff? How many people does it take to support it, and so on. So I think there's a fundamental layer of discipline and structure that's very useful and very welcome on the operational side when you bring them together. I think there's also I would say a more standardized approach to the assessment, the deployment, the use, and the reliability of technology that CIOs have had to provide for many, many years. That's very applicable in the operational space.
Thank you.
We like the analogy of we're rebuilding the airplane while we're in the air.
Yeah.
And we still have to make sure we can land it, because we only have so much fuel to keep it in the air while we're rebuilding it.
So Jeff.
Well, let me touch on, I guess, a industry use case or success story that Encore shared with me on Friday, and then I want to talk a little bit about the culture. I had the opportunity on Friday to talk to Encore CTO, and he was quick to point out, now that they fully have metered their footprint, they are saving 15 million miles a year in truck rolls. In addition to that, on blue sky days, 25% of the time when their customers call in with a service issue, they're able to solve that remotely. And additionally, when they do have to roll a truck, they have moved away from the binary as the power off or on, and they're starting to ask the questions around, maybe what is going on at the transformer? Is it a loose connection? Is it a floating neutral? But the point is you see an organization that is evolving from, black, white, off, on, to starting to get to this nirvana that we've been talking about as we started SMART, about dealing with issues, dealing with problems on our time with our resources, and eventually, obviously, proactively. So I think it's important, as we do hear success stories, that they make their way out into the industry. I see Sharon out in the audience, and whether it be SGIP, NREL, EPRI, utility collaboration, I think you're going to see the industry coalesce around some use cases. People tend to follow, and I think the same conversations are being held across the board. Maybe there is no magic use case, but there is a handful of use cases that I think the industry will, coalesce around. Obviously, as you look at OT, you see siloed. IT is going to have maybe a broader perspective. IT is probably driven more by cost. OT is driven, more by quality. You look at the metrics for OT, and it's going to be system availability. You look at the metrics for IT, and it's going to be customer sat. So, as you look at those two organizations, and you try to really juggle at the end of the day, where's the common ground? I mean, obviously, reliability is going to be important to everybody. Everybody's going to want to save money, as it makes sense. And I really think an area where you see those two coming together really is around cyber. And I think that's an area where both can come together. And if you find that common ground, you look at, whatever framework it is, an ITL framework, best of operations, best of IT, you find that commonality and you go from there. So, that's sort of my knee jerk on the cultures per se.
Thank you. Wade.
Mike, if it's okay to weigh in, I think that probably, looking at some of the other sessions, we as a group might focus a little more on culture and behavior than maybe some of the other agenda topics. Really in that context, when we start to take a look at a lot of the smart grid, advanced automation type projects that have gone on the last several years in the industry, there's been a tremendous focus on the actual technology, the technology investment, the rollout, and the test. When we talk to folks, one of the things they comment on is they, maybe in retrospect, maybe should have put a little more effort into the budget around change management, around business process change, process definition. And some of the other things, you kind of asked the leading question earlier, there's the operational side of the business, there's the IT side of the business, and they both have their strengths. One of the things that we've seen with some of the folks that we've been involved in, they're not always optimally coordinated though. So they're both strong at what they do, they're both rolling out their respective missions. Their missions are becoming more symbiotic, if you will, as they work together. But the traditional organization and the traditional work processes don't always support that. So we've seen scenarios where an IT organization's upgrading modem firmware in the field on field devices when a thunderstorm's coming through an area. And obviously it's not the type of scenario you'd like to have, but kind of working their charter, working their activities as they go forward. So you asked a little bit about best practices. Something I don't think it's truly a best practice right now. But we've seen a lot of utilities kind of scratch their heads at their existing organizations with some technology investment, wonder what they can do differently, and have looked at almost functional decomposition in the organization. So as they look at a major technology investment, they're kind of not necessarily just replacing kind, but take a step back and take a look at the use cases that they're going with. Look at what type of functions they need to put in place in terms of the people and the process activities, and then use that to drive organizational change. I think it's an early trend right now in the market, but I think it's one way we're going to see some of the traditional organizations work together more effectively.
Okay, thank you. And I guess to continue talking about the cultural questions, one of the things that I've also heard in a lot of control rooms throughout the world, there's also conflict. For example, engineers will say, I want this new screen, device, whatever, and I want it now. And there's a more formalized testing process on the IT side. And so functionally, you sometimes see that as a preponderance of Excel spreadsheets or those kinds of things or workarounds. And similarly, I guess that pulls out to the point that both sides of the organization may have different risk tolerances or frankly even contextualizing risk differently. So to continue talking about that, Matt, would you mind can you give some examples of those kinds of situations?
Well, I mean, there are a number that we're seeing coming that are more, but I mean, just even the basic technology. I went out when I first came to DWP, went out with the head of the power system to our energy control center. And we're a little different in that, and again, it's historical and somewhat technology-based. We distribute it at 4.8 kilovolts. So we have a lot of substations, right? And some of the things you're seeing in distribution management with intelligent switching out in the beyond the substation is really less relevant. If you have substations of the numbers we have, if we automate the substation, you're probably, in most areas, not going to go much farther than that. Right? But our energy control center wants to control all the way down to the low side of the substation, which means almost every distribution automation product you look at is not designed to work with our architecture. But that's a little bit of a digression. But it's important to understand, so the energy control center is dealing from generation all the way down to the substation level. I went out there, and the walls around, the high walls all the way around have basically a drawn-on model of our distribution system so that the guys in the control center can really look at the thing. The problem, we have a good electric model that the electric trouble people have of the distribution system that's GIS-based. The Energy Control Center had no access to it. They didn't see it, and if their thing on the board was a month out of date or 2 months out of date, they didn't know what was going on. So bringing some of those technology, you go out there now and there's walls of screens. They have the ability to bring up various different types of information that they never had before, and they're appreciative of that, bringing that there. But it was that they were in their own silo, and they knew that what was on the wall would be there, and it's they still keep the wall up because sometime, some of that other stuff may, flake out on them, so they want their backup, and that resiliency, that level of resiliency, is embedded in those guys. So maybe that's a good example. I think we're going to see it much more as we get into things like relying on demand response to help balance the grid. We're doing some experimental work with USC and UCLA using open ADR control into their campus energy control systems. And it's a part of a smart grid project. And so far, we're seeing very encouraging results out of it. And then as we look across LA, we have a lot of big, very large buildings that will have very sophisticated energy control systems. And frankly, I think in the long run, that's going to give us a much better connection for demand response and trying to do something at the residential level. But again, you get to the energy control guys and they'll say, well, I need so much in so many seconds, because they're thinking about balancing the grid and not their load shaping for the day before or during the day. And getting all those cultures together is the work, and getting them comfortable that the technology can work, and that once you've set some of these things up, they will see UCLA shed 4 to 6 megawatts when they send that signal out, because we've tested it numerous times, and the campus is very comfortable with how that works.
Okay.
Yeah, I think there's no bigger factor than the workforce. I think that, we were talking earlier about the impact of the millennials as they come into this environment, and we certainly hope they do in sufficient numbers, right? I mean, that's an issue in itself. I have kids in the 20s, so I still get to observe this firsthand, and they don't separate. Unlike somebody, I don't know if all of you were in the kickoff session last night, but there was a term I hadn't heard before called referring to people like me as graybacks. Did any of you hear that? No, it's kind of alarming. But we think about how we use technology. As younger folks don't separate the job from the technology. It's kind of the same thing, and they expect it to be there. And I think the piece of this that will have a beneficial impact is implementation of operational technology is, if all it is giving people more decisions to make and more buttons to push faster, then we've probably failed. There's an aspect of this, almost all this technology that we're putting out in the field collects data in some form. If we have to bring all that data, again, to the CIO, hopes this doesn't happen, if we have to bring all that data back to a central source, do things with it, present it in a certain form so somebody can make a human decision, we've kind of missed the boat, right? So there's a machine-to-machine aspect to this. When they talk about grid automation, it's really automation. So I think the key will be, this plays into the cultural aspect and the workforce aspect of it, moving to taking hands off some of these key decisions. Making it so that there's not a human interface required to make all the key effort, and using things like machine-to-machine communications, which are evolving so fast across all industries, so that we're not so dependent on individual expertise, perspective, and timing. I think that's probably, given the number of people that we have of such high levels of capability and expertise that are going to leave their jobs in the next number of years, we're going to have to hope that works.
Yeah. And to kind of pull that thread even a little bit more, that also adds more challenges on the human side, because ultimately the more these devices are acting on everyone's behalf and then suddenly may move outside of a range of tolerances and give control back to the human being. We actually saw a similar thing happen in aeronautics when we moved to a lot of autopilot systems, and at first they were basically just a red light on or off with a switch, and that was it. And so the term that they would use is, if that light went off, you had 11 seconds or the rest of your life to figure out what was going on and what to do. And so, certainly pulling some of those lessons learned into this industry is also really important. The more the system becomes dynamic, the more situation awareness and, frankly, trust plays such a key part into this. So, Jeff?
Well, and again, I just saw Raiford peek around the corner. I know he had wanted us to bring up interoperability, and I'll sort of juggle for him for a little bit till he joins us on stage. But as we've seen the investments, post-stimulus, to your point about big data and the data all coming back to a centralized location and the various stakeholders not being able to have access to the operational data, I do think we need to look at architectures, technologies that unlock that data and share data across energy applications much closer to the problem, supporting distributed intelligence. I know that's a key message you're going to hear from Raiford. He's been in several large initiatives around Coalition of the Willing, which is vendors willing to collaborate to publish data to each other. I'm sure Raiford will touch on Open Field Messaging Bus, Coalition of the Willing. Glad you could join us. And we're just sort of talking a little bit around unlocking some of how big data challenges or impediment to ITOT and realizing some of the value.
Great, thank you. And my apologies for being late. I've discovered, I'm new to Texas, that I-35 is not actually an interstate. It's a parking lot. And so I ran into some interesting traffic coming over here. My apologies.
Oh, it's great to have you here.
Come visit LA.
There's congestion on the grid, there's congestion on the roads. So, Wade, if you don't mind, we'll finish with you. And
Sure.
Your perspectives on culture.
Yeah, I mean, I think some very interesting points made. I think, Matt, you talked about kind of the vestiges of the circuit configuration up on the wall. It was a much more static environment then. You had very limited visibility, very few things that physically operated or moved, so it didn't need to be updated as much. And as Robert mentioned, we have a much more dynamic scenario right now. We have many other situations playing on the grid, different operational strategies. Jeff alluded to a lot of activities underway in the industry that I would say kind of are shifting our traditional centralized approach to more of a centralized management, but allowing for more distributed control. And that distributed control really allows us to take advantage of the automation, improve the performance of the grid overall. But it does require a different approach, both technically and operationally from a people perspective. And I think we're in an interesting transition right now. We're in the very beginning. I mean, I had a chance to work a couple storms with a utility in the Northeast, and it was fascinating to watch the veterans who preferred to use rules of thumb, printed circuit maps. They like to look at long lists of tabular data and look at actual numbers to look for trends and hunt for things themselves, while they had apprentice engineers working with them who really kind of struggled to relate to some of those techniques and much preferred dashboards, much preferred being able to manipulate the raw data and perform visualization. Both seem to have a sense of the operation of the grid and how it's characterized, but they came to it from two very different paths. And I think that right now we have processes and we have businesses that are set up maybe more so around the traditional approach to some of these things in the operation of the grid. And what we're going to see is we're going to see this other side of process change catch up to some of the technology investments that have been made in the last 5 years. Be a little bit of a rocky road along the way, but I think we'll be able to see a much more dynamic and more precisely controlled grid in the next several years.
Thanks. Well, if the good news is if boredom is the enemy, we're completely winning. And so as we're talking about different groups of people talking with each other and working with each other, we also need to keep in mind that we have all of these devices that we need talking with each other as well. So if I can turn it to you, Raiford, and ask you to talk a little bit about interoperability. Excuse me.
Sure, yeah, so I would say interoperability is kind of an interesting concept we often think about for computers, but I think back to your point, Wade, and Jeff, yours too, which was so much of interoperability that we have a problem with is actually people silos. And much of our business, what they do for data, for analytics, for operations, is built up really around a particular silo, and those silos frequently are not interoperable. They frequently view the world in very different ways rather than how do we harmonize them together. Solve these problems is not a kind of a one-off solution for metering or for any particular area. It's really all of them working together. Much of the systems that we have don't work well together either. And so a lot of the work that we're trying to do with SGIP, Controlled Message Bus, or coalitions that we've been building are really to advance interoperability of technology, but technology is really only the easy problem. The harder one is getting everybody else to actually collaborate and work together. And so from that perspective, a lot of what we've been doing is focusing on the technology, to use standards-based solutions, to federate data at the edge of our networks, to enable analytics, and the use of this great system we've been putting in place. The problem is trying to get all the other departments now to play nice and work well together to use it once we've got it.
So do you still see the kind of centralized control modality, or do you think that things are decentralizing?
Well, I think it's not a black or white solution. It's neither all one or all the other. It's actually a blending of the two. And it's a lot like when we had mainframe computers. You know, IBM was kind of the top dog, and everybody thought mainframes were the way to go. And that's a very centralized way of doing computing. Of course, clearly that didn't win out because we all have iPhones and tablets and everything else. And mobility is king. Well, the same thing is happening in our space. We're very centralized. It doesn't mean that centralized computing goes away. It just means it's more specialized for particular purposes that it's well suited for. Meanwhile, things that are really suitable for the edge, for fast-acting sort of solutions, or for light data type solutions, you know, you use that at the edge. And so really I see this as augmenting the capabilities of those existing centralized platforms to make them run more efficiently and to give them more granular control, whereas today they're kind of dealing with things at a macro perspective.
So just like we've moved sort of back towards a somewhat centralized model with the cloud kind of philosophy, you could see those two working together.
Sure.
That's really interesting. Thank you. So given that we've got a few minutes left on the panel, I'd like to open up to the audience for any questions. Do we need a mic, or should we just repeat? If you have any questions, please. Sir.
First of all, it's a great panel. I like the diversity of the participants. From experience, I'd like to pose a question, and this is more a general question for the utilities and the service providers. I had a manager a long time ago that said, never let a good crisis go to waste. And when we talk about ITOT convergence, I'm very happy to hear the discussion about the human element. Right? I represent utilities as a trade association called UTC, classically OT telecom professionals. We have members that are literally buying parts for 40, 50-year-old microwave links on eBay, and then making sure that they have a couple spares in case power goes down. You know, that's the nature of that OT industry. It's legacy of service. It's almost cultish, to be frank. They're now getting phone calls and emails from service providers saying, you know that T1 line, you know that TDM service, you know that copper line. Yeah, we said 10 years, we met in 6 months. And 2 weeks later, well, 6 months, it actually went down last night. I know you noticed it because you called me 9 times. We're not going to repair it for 2 weeks, right? There's a great crisis brewing in the space, and it's going to require, probably for the first time, what I don't mean is to belittle the scope of the executives and utilities. For the first time, utilities that relied on networks that are 30, 40, maybe 20 years old, they're going to have to make significant investments on replacing them immediately with IP-based technologies, wireless, fiber legs, very expensive infrastructure. You've got service providers, you've got technology providers, you've got consultants that have been living this in other industries. Are we as an industry prepared? And is that human element, what do we need to do to make that human element better prepared to take advantage of this crisis? Because we could look at an entirely new data infrastructure utilities in the next 5 to 10 years, certainly, based on the fact that the legacy equipment is no longer serviceable.
I'd be glad to comment on it. I mean, fortunately for us on the power side, we basically run our own telecommunications to a vast degree. So my staff, I mean, is very involved in UTC. maintains microwave rings out to the middle of Utah for where some of our big generation is, and up to the Oregon border, so we have control over the transmission that we bring down from the Pacific Northwest once it passes out of EPA's hands. And that's a lot of work, and it is using, you know, we had a big project to replace, do a full upgrade of our ring that went up to the Northwest a few years ago. And we had, you know, like a 10-day outage window to replace, to bring up the entire microwave ring, which I think is like 30 stations, right? So everything had to be pre-positioned, everything had to be tested, and then you had a few days to cut it over and make sure it worked. And that is a difficult thing. You know, we've been in the process of replacing all our traditional telephone gear and moving it to voice over IP. Well, if you have hundreds of operational locations, and some of them were strung from another location out. I mean, we owned our own copper, so we didn't end up very much in the problem people are facing. On my water side, I do have that problem, because they said, oh, we don't want to mess with you guys. We're going to do our own thing. We're just going to buy it from providers, and they have a whole bunch of the water SCADA system that's relying on circuits that are going to go away in another year and a half. So it is there we're facing that crisis much more head on, because they didn't want to come into the network. Well, they are now in a much bigger way. We run our own fiber. We have a small fiber business on the side where we lease fiber out and provide high bandwidth services to most of the studios in LA are customers of ours, as are the universities and some of the other large businesses. So we're in a little bit better position than most of the utilities to survive it, but it is a huge issue that we're facing out there.
Bob?
Well, when I heard you're quoting your old boss about don't waste a crisis, well, immediate thing that jumped to my mind was Hurricane Sandy. And if you look at what how the bar is moving in New York State with the REV actions, reliability is not enough. You got to have resiliency. Right. And in my mind, that's a much higher bar. So in the redefinition of the role of distribution utility in New York State, which is far from complete, they're still trying to figure this out, and they're trying to figure out the hard part, like who pays for stuff, right? That's so the model has been described, but not from a technology and a process standpoint, not from an economic standpoint. But when you look at the reaction to that crisis, 3 years ago, you got some pretty big utilities in that environment, Con Edison, Iberdrola, you know, and others, who have done a very good job of being reliable to the point where they're sort of optimizing their economics and their performance. The bar's been moved, and I think what you'll see in New York, and it'll be either good or bad example for everybody else, you're going to see large-scale replacement of that operational environment for all of those companies in a relatively short period of time. You know, they're at the intersection point of complete change in the regulatory environment, to activist regulators, to a change in the technology environment. There's tools to use that haven't existed before, and so I think we're going to see over the next 3 to 5 years a sea change there that, like with deregulation in California, everybody kind of sat back a little bit and said, I'm going to see how that goes before I do too much. But that's a crisis that I think is going to pay off in a lot of ways for us as an industry, and hopefully is a good example, but at least as an example.
I mean, quickly, all I would say is, you know, we're working with some of the utilities in the southeast, you know, that are losing the 4-wire copper, and you know, and whether it be Metcalfes Law, I mean, assuming there is no value in the network, but it's what's on both sides of the network. How do you not try to put one network out at a time? How do you get the different silos, the businesses, the operations to sit down together and say, let's look at this, let's have a holistic conversation. We throw this term around, but let's not try to solve every problem in an individual silo. So maybe it's an opportunity. I know it's a crisis, what they're up against, but you know, maybe you'll end up getting more people to the table for a conversation.
I do think it's an opportunity. I mean, I also look at it, and you know, unfortunately, I don't think as many of the companies are as situated as you are, Matt, I mean, at this point, you're like you said, you have a lot of your infrastructure yourself to support, at least on the electric side. I do think there is an opportunity to leverage some work that's out there today, though. I mean, if you're faced with a situation where you need to replace some network infrastructure fairly quickly, I mean, one thing I would look at is some of the emerging industry reference architectures for ITOT convergence. A lot of these have been designed to try to be media independent, to try not to focus on one particular infrastructure technology. And I think, depending on, I mean, there's some that have been developed by the federal government, some developed by industry and standards organizations. Most of the major consulting firms have their own architectures. There's a lot of overlap and there's some similarity in them, fortunately, because many of them point to similar techniques and standards. But I think that you can leverage some of that to at least get a game plan together and to try to go after a technology procurement. It doesn't help you in the time-wise, it doesn't help you in the interim operation aspect of it, but it does at least help you take advantage of a lot of work that's that's been conducted in the industry that should move you in the direction that folks functionally want to go to going forward. So I'd say, look at those reference architectures for some insight and replace it at the pace you can.
I would just say, since we're going to quote old bossisms, I'll quote one from mine, which is to say, get comfortable being uncomfortable. So much of what we're doing here is, hey, I'm going to replace this 20, 30-year-old technology with technology that'll last me 20, 30 years. Yeah, not going to happen. Your use case is, so I'm a computer scientist by original training, and when I did that, I had another WAG of ours, a mutual colleague, that said I could always design a network that a programmer could break instantly, right? Because they always need more bandwidth and lower latency than what I got today. So much of what we do is we line up a set of use cases and go build a network to meet that need, rather than be forward thinking about how do I make all this stuff work together and how do I create capacity, and really how do I make flexibility where I don't have it. And the problem is that we're thinking of it like, well, like electric utilities, gas utilities, and frankly the telecommunications providers, that's their job, that's what they do well. And so I don't necessarily think that means you go outsource everything or insource everything. I think it means your strategy for doing things needs to be flexible, needs to contemplate doing things well beyond what you do today. And once again, get comfortable being uncomfortable, because that's going to be the status quo going forward.
I just want to make one comment. And I thought when you talked about some of the reference architectures, because there's, we run into also a collision sometimes with our regulators. And the case I'm thinking about specifically, and this, I mean, I spoke on this at a UTC national conference a few years ago, was where we were with MPLS and NERC. Right? I mean, MPLS is a very standard architecture that's designed to allow you to have some real flexibility and security and ability to keep things very separate. It took, and we still don't have an absolutely clear decision as to whether you can use MPLS to separate, from an electronic perimeter standpoint under NERC, your networks that are between control and others. So you end up having to build all this crazy stuff in there because you can't get, everybody's afraid to make a decision. And in some places, the auditing groups, right, which are regional, are saying it's okay, and in other places they're saying it's not. And that is absolutely a core decision in terms of how you architect your network going forward. And it's been 3 or 4 years that we've been asking that question, and I know the vendors, Cisco's been pounding on them to try to get an answer. And we're still sitting in this, well, it depends what your regional auditor is going to be, who changes every couple of years. Yeah. And we can't rely on that, on what will be, millions of dollars of investment to retool our networks to be able to support the kinds of information flows and automation that we're seeing ourselves needing in the next 10 to 15 years. So that's one that where you adopt an architecture, you start moving forward, you start delivering that way, and then you go, oh wait, but I can't take it beyond this level. Or I have to build a totally separate one even though it's the whole purpose is for that resiliency and that ability to separate things and keep them very secure. It's a crazy world we're stuck in there.
Discomfort abounds. Questions? Sir?
Hi, I'm Bill Meehan with Esri. Matt, you had a very interesting point, I thought, when you said that there are really two ways that you can kind of get to the same point. An experienced person that was kind of using their own, kind of an older person, and then maybe the young folks. My question is, there's a tremendous, or my comment, there's a tremendous value, I still think, in some of this experience. How do you take that experience when we know all of these people are going to walk out the door within the next couple of years? What do you do about that? How do you capture that information?
Is it,
Sure.
Yeah, so maybe just to start off, I don't think I have the only answer on this. I mean, I've seen a couple approaches. I'm not sure which is the most effective. One, I've seen some utilities in the Northeast have been fortunate enough to be in a position where they kind of have an engineer and training type of a program or an activity for some of their new hires. And that's the experience I was mentioning, was the two working together on an outage and explaining to each other how they analyze the outage and how they augment the reports, the standard reports they get there. And both tried to gather an appreciation for each other's approach. And I think both benefited from watching each other come at it differently. So there's the personal experience and the personal interaction. I mean, the less human one is the knowledge repository, right? And how to package the lessons learned, how to convert them into use cases that become business processes, and hopefully turn that into a process. Although over time, I think you lose the essence of what that key piece was. So while I think there's value in that, it's not clear to me there's as much value as having the time to kind of shadow someone and to learn and to cross-pollinate before you lose that experience, and then augment it with some of the key lessons learned through information, process change, maybe things like that. So at least that's one take.
Anyone else? Okay, great. And another question? Sir?
Yeah, this is Jeff Sharple from Intel. How do you deal with maintenance if you're distributing intelligence out to the edges? Now you're trying to maintain assets that may be there for 2 years instead of your assets that are there for 50 years. So you sort of switch assets that you need to maintain. How do you think about that? How do you deal with that?
Anyone want to?
Well, I mean, we deal with it in the IT side all the time. It's getting that into the OT environment. And some of it is, and I'll give you an example. We're doing sort of our second generation of substation automation, right? The first generation, what were some of the issues we ran into? Well, when SIP came along, we started seeing these Windows 2000 servers in the substations that couldn't be upgraded. And all of a sudden they went, oh, you mean we have to do something with this, right? So we got much more engaged. The IT side got much more engaged. But so now they're into the second generation, and the newer stuff is all IP based. And they came in with and my side does the network engineering group for the OT side as well. So we're very converged at the network engineering side, and that's been well accepted. And frankly, all my network engineers come out of electrical engineering, so they tend to be more accepted because we are an electric utility after all. But we had this thing where we were bringing the network to the substation, and we had sort of our standard routing method. And in the old days, there was a server in the substation, and all the control came through off that server. Well, now it's all IP, so what they wanted to do was bring in another switch that they would maintain, even though they don't know anything about switches, that would connect from this switch to this switch, and then they'd run it. And we said, no, that's crazy. One, the people who know how to maintain that stuff are already maintaining this switch in your substation and have been for the last 10 years, and those guys, and they're all NERC certified, everything about them. Why are we going to bring another device in to do the same thing? It's not adding redundancy, it's just adding another layer of complication. And we sat down and we got past that, but it was them giving up the notion that they had full control over this whole control system. And that was a big change. That took a lot of working through, even though for years we've been doing an awful lot of the stuff right into the substation itself. But yeah, we do have to maintain that, and it is a bigger issue, and to the degree we can do it remotely, thank God for some of the remote tools that allow us to patch and do those things remotely. Otherwise, it would be an enormous mess.
So I do apologize. We have only time for one more question, but I hope you'll feel free to stick around if we all can. We'd love to keep the conversation going. Sir? Okay.
Okay, great, thank you. I guess,
Thanks,
can you guys touch on the rise of, so Ricky Bush from GE, can you touch on the rise of distributed generation as sort of a force and function for ITOT? And I guess a related question that would be, how do you guys think about overcoming some of the challenges associated with acquiring data from customer-owned or sited equipment that's required in this technology?
So I'll take a first shot. I'll do a quick hyper-caffeinated version due to the time constraint. Really, there are 4 major events that are happening to our industry. Distributed energy resources, battery storage, renewables, that's one. Metcalfes Law is another, right? The value of the network being interconnected, that's another. Moore's Law, making things more computationally efficient, building out technology. And of course, the 4th one is big data analytics. All of these are really coming together to really change our industry to say fundamentally generation is no longer central station, it's now distributed control paradigms. Instead of being centrally, now must be distributed. Literally, interaction can no longer be, it's all about control, right? If I had control over my universe, which is how I used to do it, everything's easy. Now what we're saying is I got to share. I got to find ways to partner with data, partner with other players, partner with other networks. And that's just an entirely different paradigm shift from where we've been. And really, I see that's our biggest hurdle in not just distributed energy resources, which are shifting the need to have faster acting and distributed systems, but all the rest of those playing together to really enable the capabilities to do something useful with it.
Any last comments from anyone else? Okay, great. Well, I thank you so much for all being here today, and hope you all enjoy the rest of the conference. Thank you.
Thank you very much.
Thank you.